Dear students, greetings to you. Let me first welcome you to the Wireless Technologies module. I am Suresh and I will be facilitating this module. The module is considered to be moderate in terms of the difficulty, and the pass percentage has been over 70% that can be seen from the past cohorts. We will be doing short lectures followed by activities in Blackboard. The learning is designed to encourage independent learning. There are both internal and external assessment components. You will be submitting 3 internal assignments that contributes 40% and one final assignment contributing 60% to your final grade. With this preamble, let us start this session that gives you an introduction of what is wireless technology. This session provides an introduction to wireless networks in general and wireless LANs in particular. It describes and explains what the different wireless technologies are, their main features, security issues, advantages, disadvantages, and uses or applications. Let us start with the definition of wireless networks. Wireless networks are networks that use radio waves to connect devices without the necessity of using cables of any kind. Devices commonly used for wireless networking include portable computers, desktop computers, handheld computers, personal digital assistants, shortly abbreviated as PDAs, cellular phones, pen-based computers, and pagers. Wireless networks work similar to wired networks. However, wireless networks must convert information signals into a form suitable for transmission through the air medium. Wireless networks serve many purposes. In some cases, they are used as cable replacements, while in other cases, they are used to provide access to corporate data from remote locations. The most important thing that we have to understand is that wireless infrastructure can be built for very little cost compared to traditional wired alternatives. Wireless networks allow remote devices to connect without difficulty. Independently, these devices are a few feet or several kilometers away, and no need to break through walls to pass cables or install connectors. This has made the use of this technology very popular and it's spreading rapidly. Wireless networks can be classified into 4 specific groups according to the area of application and the signal range in which they actually work. For example, the first classification is the wireless personal area networks, abbreviated as WPAN. The signal range is within 10 meters for WPANs. The next classification is known as the wireless local area networks, abbreviated as WLANs, and for WLANs the signal range is 100 meters. We are also aware of the wireless metropolitan area networks, again abbreviated as WMAN, and the signal range for a wireless metropolitan area network is 50 kilometers. And now we have the wireless wide area networks, abbreviated as WWANS, and the signal range is beyond 50 kilometers in this case. The signal range doesn't stop there. Here in this image, you can see the ranges beyond 100 kilometers. Please see the range that shows communication range pertaining to medium wave, short wave, and satellite. Let us all look into the detailed descriptions of all these classifications. Wireless personal area networks are based on the IEEE 802.15 standard. For more details about this standard, visit the Wikipedia link shown in the slide. They permit communication in a very short range of about 10 meters. Unlike other wireless networks, a connection made through a WPAN involves little or no infrastructure or direct connectivity to the world outside the link. This allows small, power-efficient, inexpensive solutions to be implemented for a wide range of devices such as a smartphone and a PDA. Wireless personal area networks are characterized by low power demands and a low bit rate. Such kind of networks rely on technologies such as Bluetooth, IRDA, which is commonly known as the Infrared Data Association, ZigBee, or UWB. From an application point of view, Bluetooth is intended for a cordless mouse, keyboard, and hands-free headset. IRDA is used for point-to-point links between two devices for simple data transfers and file synchronization. ZigBee is designed for reliably wirelessly networked monitoring and control networks, and UWB, which is also called as the ultra wideband, is oriented to high bandwidth multimedia links. Now let us have a look at the Bluetooth network. This is also called a PicoNet and is composed of up to 8 active devices in a master-slave relationship. The first Bluetooth device in this network is the master, and all the other devices are slaves that communicate with the master. This network typically has a range of 10 meters, although ranges of up to 100 meters. It can be reached to 100 meters under ideal circumstances. To provide security, each link is encoded and protected against eavesdropping and interference. Two networks comprising of Bluetooth can be connected to form a scatter net. A Bluetooth device may participate in several PicoNets at the same time, thus allowing for the possibility that information could flow beyond the coverage area of a single PicoNet. A device in a scatter net could be a slave in several PicoNets but master in only one of them. In the image shown, you will see a point-to-point infrared data association communication between a PDA and a printer. Another typical example that we use every day is the television remote control. The Infrared Data Association, that is IRDA, specifies a complete set of infrared communication standards. IRDA refers to that set of standards and is used to provide wireless connectivity to devices that would normally use cables for connectivity. IRDA is a low-power, low-cost, unidirectional, narrow-angled ad hoc data transmission standard designed to operate over a distance of up to 1 meter and at speeds of 9600 bits per second to 4 megabits per second. It's interesting to note that it's under development to work under 16 megabits per second. Some of the devices that use IRDA are notebooks, PDAs, printers, and cameras. Now, the other two examples under this classification is ZigBee and UWB. Now, I want you to do a research about these two technologies to find out what they actually mean, their transmission methods, understand their purpose, and also the frequency allotted to them, if any. I want you to submit your findings, and this will be your first graded internal assignment 1. Remember to list down the references using Harvard style of referencing and also the inline citations. Like I had mentioned, I want you to submit your findings, and this will be your first graded internal assignment 1. Remember to list down the references using Harvard style. Please refer the assessment resources for further details and submission link, which is available in your Blackboard page. Now, the next classification, which is the wireless local area network, which is abbreviated as WLAN or WLAN. WLANs are designed to provide wireless access in areas with a typical range of up to 100 meters and are mostly used in home, school, computer laboratory, or office environments. This gives users the ability to move around within a local coverage area and still be connected to the network. WLANs are based on IEEE 802.11 standards marketed under the Wi-Fi brand name. Due to the competition, other standards such as HyperLAN never received much commercial implementation. IEEE 802.11 was simpler to implement and made it faster to the market. The complete family of IEEE standards will be revised in more detail, perhaps in the later sessions. The IEEE 802.11 is a family of different standards for wireless local area networks. The IEEE 802.11b was the first accepted standard supporting up to 11 Mbps in the 2.4 GHz unlicensed spectrum band. Then the IEEE 802.11g standard was designed as a higher bandwidth successor to the IEEE 802.11b. An IEEE 802.11g access point will support the 802.11b and 802.11g clients. Similarly, a laptop with an IEEE 802.11g card will be able to access existing 802.11b access points as well as the new 802.11g access points. That is because wireless LANs based on 802.11g will use the same 2.4 GHz band. The maximum transfer rate for the IEEE 802.11g wireless link is 54 megabits per second, but it will automatically back down from 54 megabits per second when the radio signal is weak or when interference is detected. Now let us discuss the next classification, which is WMANs, which actually stands for Wireless Metropolitan Area Network. And this is the third group of the wireless networks. And WMANs are based on IEEE 802.16 standard, which is often called WiMAX, Worldwide Interoperability for Microwave Access. WiMAX is a communications technology that supports point-to-multipoint architecture aimed at providing high-speed wireless data over metropolitan area networks. This enables smaller wireless LANs to be interconnected by WiMAX, creating a large WMAN. Thus, networking between cities can be achieved without the need for expensive cabling. Since I mentioned about WiMAX in the previous slide, it is important for us to appreciate the distinction between WiMAX and Wi-Fi. WiMAX is similar to Wi-Fi but provides coverage over greater distances, while Wi-Fi is designed to provide coverage over relatively small areas such as in offices or hotspots. WiMAX operates on two frequency bands, a mixture of licensed and unlicensed band, from 2 GHz to 11 GHz and from 10 GHz to 66 GHz. It can transfer around 70 megabits per second over a distance of 50 km to thousands of users from a single base station as depicted in this image. As it can operate in two frequency bands, WiMAX can work by line of sight and non-line of sight. At the 2 to 11 GHz frequency range, it works by non-line of sight, where a computer inside the building communicates with a tower or antenna outside the building. Short frequency transmissions are easily disrupted by physical obstructions. Higher frequency transmissions are used for line of sight service. This enables two towers or antenna to communicate with each other over a greater distance. Wireless wide area networks extend beyond 50 kilometers and typically use licensed frequency. These types of networks can be maintained over large areas such as cities or countries via multiple satellite systems or antenna sites looked after by an internet services provider. There are mainly two available technologies: digital cellular telephony and satellite systems. In the cellular system, the coverage area is divided into cells. A cell transmitter at center of the cell is designed to serve an individual cell. All transmitters are connected to a base station and these latter to a mobile telecommunications switching office, which links the cellular and the wired telephone network. The system seeks to make efficient use of available channels by using low power transmitters to allow frequency reuse at much smaller distances. It is interesting to see the evolution of cellular generations. Different cellular generations have been developed since the early 1980s. The first generation, 1G, was analog and conceived and designed purely for voice calls with almost no consideration for data services with a speed of up to 2.4 kilobits per second. The second generation, 2G, was based on digital technology and network infrastructure (GSM), enabling text messages and with a data speed of up to 64 kilobits per second. The 2.5G generation was between the second and the third. Sometimes it has been referred as 2G plus GPRS. It is an enhanced version of 2G with a speed of up to 144 kilobits per second. The 3G generation was introduced in the year 2000 with a data speed of up to 2 megabits per second. The 3.5G is an enhanced version of the 3G that uses HSDPA to speed data transfers up to 14 megabits per second. Finally, the fourth generation 4G is capable of providing up to 1 Gbps, that is 1 gigabits per second speed, and any kind of service at any time as per user requirements anywhere. Now, since we are in the year 2020, I would say we are moving towards the 5G generation. Now, let us see how a satellite system is applied in a wireless wide area network. Wireless communications can also be developed via satellite. Due to its high altitude, satellite transmissions can cover a wide area over the surface of the earth. This can be very useful for users who are located in remote areas or islands where no submarine cables are in service. In these cases, satellite telephones are needed. Each satellite is equipped with various transponders consisting of a transceiver and an antenna. The incoming signal is amplified and then rebroadcast on a different frequency. With this, we come to an end of this session, and I hope you will be able to appreciate the differences of various wireless networks. Now, I want you to answer these questions. In the next session, we will be discussing various terms that are used in a wireless network architecture and modes for configuring a wireless architecture. Now, let's move on to the questions. Now, I have listed 3 questions in this slide. So, the first question is, from what you have understood, explain wireless local area networks. The second question is, discuss in detail the architecture and application of Bluetooth networks, and finally, what are the examples of wireless communication systems. Now, I want you to answer these questions. This is available in the discussion forum. So I want you to post the answers in the discussion forum by creating a thread for yourself. So please note that this is mandatory and I want you to complete this before the next session. Thank you. Thank you for your time, and please note that I have posted the PDF version of this slide in the Blackboard. Have a nice day ahead. Cheers.